A riser clamp is a type of hardware used by mechanical building trades for pipe supporting vertical runs of piping risers at each floor level. The devices are placed around the pipe and integral fasteners are then tightened to clamp them onto the pipe. The friction between the pipe and riser transfers the weight of the pipe through the riser to the building structure. Risers are generally located at floor penetrations, particularly for continuous floor slabs such as concrete. They may also be located at some other interval as dictated by local building codes or at intermediate intervals to support plumbing which has been altered or repaired. Heavier piping types such as cast iron require more frequent support. Ordinarily, riser clamps are made of carbon steel and individually sized to fit certain pipe sizes. Riser refers to vertical runs of pipes, electrical conduit and tubes. There are at least two types of riser clamp, the two-bolt pipe clamp and the yoke clamp.
A street elbow, sometimes called a street L or service L, is a type of plumbing or piping fitting intended to join a piece of pipe and another fitting at an angle. The difference between a street elbow and a regular elbow is the nature of the connections on either end. A regular elbow has a female hub or FIP connection on both ends. A hub is a female ABS, PVC or copper pipe receptacle. FIP denotes female iron pipe threads, that is, it receives threaded MIP iron, brass or plastic pipe on both ends. FIP is also known as FPT, female pipe thread, and MIP is also known as MPT, male pipe thread. Collectively, these are known as National Pipe Thread (NPT) fittings. Instead, a street elbow has a female fitting hub or FIP on one end and a male pipe or MIP fitting on the other end. The advantage of the street elbow is that it can be connected directly to another fitting without having to use an additional short connecting piece called a pipe nipple. Street elbows are available in 90 degrees, 45 degrees, and 22.5 degrees bends. They can be used in water supply, drainage, sewers, vents, central vacuum systems, compressed air and gas lines, HVAC, sump pump drains, and any location where plumbing fittings would be used to join sections of pipe. The Natural Gas and Propane Installation Code of Canada B149.1 states, "A street elbow or a street T shall not be used in a piping system." A pulsar pump is a gas lift device that uses gravity to pump water to a higher elevation. It has no moving parts. A pulsar pump makes use of water that flows through pipes and an air chamber from an upper reservoir to a lower reservoir. The intake is a trompe, which uses water flow to pump air to a separation chamber. Air trapped in the chamber then drives an airlift pump. The top of the pipe that connects the upper reservoir to the air chamber is positioned just below the water surface. As the water drops down the pipe, air is sucked down with it. The air forms a bubble near the roof of the air chamber. A narrow riser pipe extends from the air chamber up to the higher elevation to which the water will be pumped. Initially, the water level will be near the roof of the air chamber. As air accumulates, pressure builds, which will push water up into the riser pipe. At some point the air bubble will extend below the bottom of the riser pipe, which will allow some of the air to escape through the riser, pushing the water that is already in the pipe up with it. As the air escapes, the water level in the air chamber will rise again. The alternating pressure builds up and escape causes a pulsing effect, hence the name, pulsar pump. The maximum air pressure that can accumulate depends on the height of the water column between the air chamber and the lower reservoir. The deeper the air chamber is positioned, the higher the elevation to which the water can be pumped. The depth of the air chamber position is limited by the depth to which the flowing water can pull the air from the surface of the upper reservoir down to the chamber. This depth partially depends on the speed of the water, which in turn depends on the difference in height between the upper and lower reservoir. Brian White, stonemason by profession, claims to have invented the pulsar pump in 1987. He put the idea in the public domain. However, Charles H. Taylor invented the hydraulic air compressor before the year 1910 while living in Montreal. The working principle of the hydraulic air compressor and the pulsar pump is exactly the same. But the purpose of the compressor is to generate compressed air. Expelling the water up to 30-meter high serves to prevent potentially damaging overpressure. The primary purpose of the pulsar pump is to use the air pressure to expel the water to a higher elevation.